You guys hear me now? Yeah, okay. Mrs. Broadhead's group, I don't know if you were expecting her or me, but we decided to just put these all together so that you were all on the same page rather than doing two different Zooms. So let me just give everybody a minute to log in and then we can get started.
Miss Sullivan.
All right.
Miss Sullivan.
We put this assignment up late, obviously. So I don't know that I expect everybody to come. So maybe I'll get started now and then just let people in as they get here. Let me just take a picture of who's here. Okay, so I don't know if you watched it yet, but I posted a video explaining the answers to the web quest and to the physiology lab, and then explaining what parts of those you're going to see on the summative assessment on Tuesday. But I just wanted to talk a little bit more about the Ed puzzle. Hold on, this dog. Nope, you gotta stay out there. Okay, come on in. Sorry, it's gonna be a party in here today. Sorry about that. Okay, you've got to turn that off though, because I'm talking to my friends. You have to turn that off if you're gonna be in here. Take it out. So I want to talk about the Ed puzzle a little bit because that's the part that I think is probably the most confusing. Sure. You got to go find Daddy, okay? Okay, but you got to go find Daddy for that, okay? I'm sorry, guys. I think the concepts that he talks about in the Ed puzzle in the video, the crash course video, are a little bit tricky to understand, but I think if we go over just the main concepts that he talks about, it might help clear some things up. So that part of your summative assessment is going to be 3 questions long. It's on the physiology of breathing. And if you take a look at the physiology lab that you did, the one where you did the Ed puzzle first, there are 3 prompts on that assignment that you will see on the summative assessment. So those are the 3 things you have to be able to understand. So you have to be able to explain how blood cells exchange oxygen and carbon dioxide to maintain homeostasis. You need to be able to explain how changes in partial pressure, blood pH, and blood temperature change how hemoglobin binds to gases in the blood. And you need to be able to explain why the paper bag trick actually works. So first thing I want to sort of review is how the blood cells exchange oxygen and carbon dioxide to maintain homeostasis. So if I can share, whoops, where did you guys go? Let's see if I can share this. We'll just do desktop. Okay. Can you, whoops, which desktop am I sharing? Can you see this picture right here or not? You can, with like the capillaries, the alveoli. Okay, Scotty, get out of here.
Miss Sullivan.
So basically, these, I'll make this bigger. These 3 little bubbles right here, these are alveoli. So you've got the lung up here, it branches into the bronchi and the bronchioles. And then it ends, each bronchiole ends with an alveoli. And this is, they fill up with air. The lining of the alveoli is one squamous cell thin. And then there are capillaries that sort of flow over these alveoli that carry one single red blood cell at a time as they flow over. So what happens here is you have, when you breathe in, you have a high concentration of oxygen inside the alveoli, and you have a low concentration of oxygen in the blood because this blood just delivered oxygen to all the body tissues down here. Okay, so it's low oxygenated blood coming from the heart to the lungs, and as it passes over these alveoli, the oxygen concentration wants to flow from high to low. So it's going to go from the high concentration in the alveoli to the low concentration in the blood cells. So the blood cells, the hemoglobin in the blood cells are open and available and ready to pick up oxygen. So the oxygen attaches to the hemoglobin, and there are 4 binding sites on the hemoglobin to attach the oxygen. Then at the same time, the blood cells have a lot of carbon dioxide in them. So there's not a lot of carbon dioxide in the blood. So for the same reason, that high concentration of carbon dioxide flows into the alveoli, and then you exhale that out of the body. So now this blood is oxygen rich. It gets pumped back to the heart like we saw last section. And then this oxygen rich blood travels through the capillaries in the body, delivering that oxygen to all the body cells. And there are a couple different ways that happens. So that sort of explains prompt number 1. Explain how your blood cells exchange oxygen and carbon dioxide to maintain homeostasis. Any questions on that part?
Miss
You
Sullivan.
guys can raise your virtual hand if you want
Miss
to,
Sullivan.
or if there are no questions, we'll keep going. Okay.
Miss Sullivan.
Oh, yep, question. Sophie.
Yeah. Can you let Cass in the Zoom? She's
Oh,
been
I
in
can't
the
hear
room.
Sophie, do you have
Yeah.
a question?
Yeah.
No?
Yeah, I do. Can you hear me?
Oh, sorry. Let me admit these people. I got a couple more people coming in. Do I have any questions? No? Okay. All right. So then the next prompt was explain how changes in partial pressure, blood pH, and blood temperature change how hemoglobin binds to gases in the blood. So basically, hemoglobin has 2 shapes. In one shape, it's really good at binding oxygen. And in another shape, you gotta get out of here. I can't hear myself with that on. In the other shape, it's not good at binding oxygen. So when hemoglobin is in its open form and readily available to bind oxygen, it'll grab hold of it. So each hemoglobin molecule will hold 4 oxygen molecules. Then it travels to the tissues here. And the partial pressure is like what we talked about with the concentration gradient. So high partial pressure to low partial pressure is the way these molecules will flow. So basically high concentration to low concentration. In the Ed Puzzle, he talks about being on the top of Mount Everest and how because the pressure when you're that high up is so much lower, the partial pressure of oxygen in the air and in your body is almost equal. So there's no pushing of that oxygen into your bloodstream. So even though the amount of oxygen is still the same, there's not as much pressure to push it into your body, and therefore it's really hard to breathe when you're at high altitudes like that. Blood pH. He talks about how carbon dioxide makes the blood more acidic. And if the blood's more acidic, it's less likely to bind oxygen. So that allows, as the blood travels past the body cells that are getting rid of carbon dioxide, it makes the blood acidic. As the blood takes in that carbon dioxide, the blood becomes acidic and makes that hemoglobin let go of the oxygen. So that oxygen then goes into the cells of the body a little bit better because it doesn't want to hold on to the oxygen as tightly. So that's really beneficial to the body cells that need oxygen. Additionally, blood temperature changes how hemoglobin binds to gases in the blood too. So if you're working out, you're exercising a lot, and your muscles are getting warm and releasing heat, as that hemoglobin passes through that hot area of the muscle, it changes shape again and basically releases oxygen. So the muscles that are working harder are taking more oxygen away because the heat is making hemoglobin release that oxygen quicker. So that's how partial pressure, blood pH, and blood temperature change how oxygen binds to gases. So at more acidic conditions, hemoglobin has a lower affinity for oxygen, so it will let go of oxygen. And at higher temperatures, hemoglobin has a lower affinity for oxygen, so it will let go of the oxygen as well. Questions on that? And he talks about that more in the Edpuzzle too. So if you were sort of spacing out during the Edpuzzle, maybe watch it again after this and maybe it'll make more sense. Sorry, I've got two screens here and I can see you guys on my screen over there, which is why I keep looking over there, but you're actually looking at me here. So, okay. And then the third one, explain how the paper bag trick actually works to help you maintain homeostasis when you're hyperventilating. He talks about how hyperventilating is basically you're getting rid of too much carbon dioxide because your brain is tricking your body into thinking it needs to go into fight or flight mode because you're nervous, but your body actually doesn't need excess oxygen because it's not actually doing anything. And so you're exhaling too much carbon dioxide and your blood isn't picking up that excess oxygen that you're bringing in. So everything basically gets out of whack. So your blood turns more basic, right? Because you're getting rid of that carbon dioxide. So your blood's going to hold on to oxygen tighter. Oxygen's not going to get to your cells. Oxygen's not going to get to your brain as much. You start feeling lightheaded and dizzy and you're hyperventilating. So if you do the paper bag trick, you're basically re-inhaling that carbon dioxide that you're getting rid of too quickly. So you inhale the carbon dioxide, you exhale the carbon dioxide, you inhale the carbon dioxide. So that's going to lower the pH of your blood, make it more acidic again, and get you back to homeostasis quicker. Any questions on that paper bag trick? Did Cass ever get into the Zoom? I just got a message when I put Cass in the Zoom, but I don't. Oh yeah, you're here. Okay, hi Cass. All right. Any questions on any of those three concepts? I know it's a lot of information that we could probably talk about for 2 weeks. So it's not necessarily a ton of information on the summative assessment, but I just wanted to go over those three things. You can do a little research on it too. You can look at, watch the Edpuzzle again. Does anybody have any interest in going over the questions on the Edpuzzle, or did they give you the correct answers? Did they give you the correct answers when you did it? They did. Okay. Any questions on any of those? You didn't understand why they were wrong or correct? No? Okay. So in the video I posted earlier, I talked a lot about what you'll need to know for the summative assessment. So I'm not going to redo all of that. You can watch the video. I'm going to stop sharing this for a minute so I can actually see what's going on here. Can you see me? Okay. All right. So does anybody have questions for me on any of this, on what you need to know for the summative assessment? Anything? No? Okay, let me get a picture so I can show Mrs. Broadhead who came. And then that's all I have for you, I think. Everybody doing okay? Everybody ready for this to be over? Me too. Okay, well, that's all I have for you guys, unless you guys have questions for me. Hopefully you turned in the respiratory distress lab this morning. If you didn't, make sure you get that in. And if you have any questions, send me a message. Your summative assessment is going to be just like the cardiovascular system one. It'll show up on Tuesday. You can download it. You can complete it either on paper or on the iPad and then resubmit it. It's shorter than the other one. There just wasn't as much content. And then we'll hold another Zoom review to go over what you need to know for the final test for quarter 4 next week. So at this point, you're basically done with the work that you have to do. So that should feel kind of good, other than studying for that test. All right, that's all I have for you. Any questions? Nope. All right, good seeing you all. Have a good week or weekend or whatever, wherever we are. And I'll see you guys next week. All right, bye.
Thank you. Thank you.